Hi everyone, welcome to our webinar on these engineers and their roles in society. Thanks for joining us in this evening. I hope everyone actually safe and sound. Our topic, currently we all notice that the pandemic situation actually getting worse. So I hope that everyone follows strictly on the SOP and also try to reduce the unnecessary going out, stay at home as much as possible. So everyone are frontliner, so together we can overcome these pandemic situations. Okay. We're going to wait for a few minutes for allow more people to joining us. In the meantime, we're also having a live in our Facebook, Utah for You. So if you have some friends or family that not yet join us, feel free to ask them watch our live stream there. Allow me to introduce myself. My name is Ken from Division of Program Promotion Utah, and I will be the moderator for tonight's webinar. Allow me just a quickly brief through for today's rundown. This webinar will be divided into two parts. It will start with the webinar section, the topic you can see on the screen, engineer and their roles in the society. And then we'll have a short Q&A section. You are welcome to post your questions in the Q&A tab available in this Zoom conference. Once you post there, we can pick up and reply to you shortly in the end of this webinar. This webinar section will be estimated around 1 hour or less. Okay, so as you see on the screen, today our speaker is Dr. Guan Seng Hao. Dr. Guan is our assistant professor from Lee Gong Chen of Faculty of Engineering and Science in Utah. Dr. Guan previously graduated from McGill University in Montreal, Canada, in a PhD program for Materials and Engineering in 2013. He also holds a Master of Degree and also Bachelor of Engineering degree in the same field from the same department. Currently in Utah, his research interests are focused in sustainable processes and also bioprocesses, such as some microbial leaching of economics minerals and generation of solvent-coated bubbles for use in this wastewater treatment. So for those who may be interested in this topic, maybe you can post something related in the Q&A. So Dr. Guan can help you to answer your questions that related in this maybe solvent-coated bubble for these wastewater treatments. So currently we have some attendees. Actually, mic check, can everyone hear me clearly? If yes, can you type in the chat? Okay, type in the chat box so I can know you all can hear me clearly. Okay, hi. Okay, I see Patrick. Okay, thanks. So actually, without any delay, I would like to invite our speaker today, Dr. Guan. Hi, Dr. Guan, are you there?
Yes, I'm here.
Hey.
Let me just start my video feed.
Yeah, no problem. Hi, Dr. Guan. Hello.
Hi, thanks, Ken.
Yeah, sure. So I pass the floor to you in this webinar section.
Thanks.
Okay.
Sure. Good evening, everyone. Welcome to a webinar hosted by Utah entitled Engineers and Their Roles in Society. So in this webinar, I'll talk about the importance of an engineer's role in building society and constructing infrastructure around the world. Also, I'll talk about the previous historical achievements leading all the way to modern achievements, right? So if there's any questions that you can ask me at the end, I'll proceed to start the webinar. Okay, let me just try to get hold of the screen here. Let me just pause the share and reshare this. It appears to be some, the screen appears to be hanged, right? Just give me a second here. right, I'd like to apologize for this slight technical problem. Computer is hanged at the moment. Let me just sort this out. All right, the outline of the talk today will be, I'll start talking about the engineers and their roles, right? And then we'll talk about some great historical structures in the past, such as the Great Wall and the Great Pyramids. I'll also fast forward to American history in the 1800s. I'll talk a bit about the raising of Chicago. Later, we'll delve into engineers in the 21st century, some of the latest developments in materials engineering. And also, I'll talk about the field of materials and manufacturing engineering, and then followed by a Q&A session. All right. I'd like to apologize for the slight technical problem we had just now. All right. So, civilization and the engineer. So, in our daily lives, we drive around in our cars. Right now, they're petrol driven. Sooner or later, it's going to be all electric cars. A lot of cars going to be self-driven. We also pass by great structures. For those of you who live in KL, we have the KLCC Twin Towers. Just great infrastructure everywhere in the world. For those of you who are fortunate enough to travel to Europe, there is Eiffel Tower. There's also highways around the world. And we keep in touch with each other through smartphones. As well, you know, when your car runs out of petrol, we go to the petrol station and we fill up the gas tank, right? So all these things that you come into contact every day, the things that you use, the place that you work in, the structure that you drive on with your car, all this have been touched by the engineer, right? It involves the work of an engineer. For a building, there's the civil engineer who works closely with the architect, also the building surveyor to erect the building. For cars, there's the automotive engineer, right? Working closely with mechanical engineers, electrical engineers to make sure the car operates and runs well. Highway civil engineers as well, right? For smartphones, there's the telecommunications engineer, industrial engineer for the design, so on and so forth. And when you pump your petrol also, there's an engineer who's running all the calculations, right? How much petrol goes into your car, how fast the meter runs, if they all run at the same speed, and if they function well, right? So engineers are involved in every facet of modern life, right? However, if you look at popular culture, it hasn't been so kind to engineers. I mean, we know in movies there's like cops, police, there's detectives, then there's serial killers. But really, if you look closely, there's not much of engineers, right, being depicted in film. In Hollywood, for example, there's Tony Stark, right? He's an engineer. He designs his suits, drives around in supercars, right? Designs his own self-powered heart, but it's highly radioactive, right? But that's highly fictional, right? And there's the architect, the old guy from Matrix, okay? And then there's Morgan Freeman in Batman, right? Who comes up with all the cool gadgets. But there's not really any important role or character, right, of the engineer in popular culture, despite the amount of contribution that engineers make to society, right? So to take you back to the base, the word engineer is derived from the Latin word ingenium, meaning cleverness or a brilliant idea. Oxford defines it as an engineer who is a person whose job is designing and building engines, machines, roads, and bridges, right? So in modern life, engineers build buildings, designs cars, as we discussed, designs phones, so on and so forth. Engineer is a person whose principal duty is to apply mathematical and scientific knowledge to create practical devices, structures, and processes to serve mankind. He or she designs materials, structures, machines, and systems while considering limitations imposed by practicality, safety, and cost, right? Engineer first start being termed the engineer during the Industrial Revolution in Europe in the 18th century. Back then, there were only two branches, right? Military and civil engineering. Military, as some of you may know, is concerned with construction of forts, barracks, and military weapons. Civil engineering, on the other hand, was devoted to building of infrastructure such as roads, bridges, buildings, drainage, and water supply systems. Right? So picture on the right here, we have A Formosa, which is a fort built by the Portuguese in Malacca back in the 1500s. And then we have a random, I believe, a North American city where they are laying down foundation, right? Underneath the city, right? So today there are many main branches of engineering that evolved from the original civil engineering. There's civil engineering itself. There's mechanical engineering, right? Guys who design pumps, ventilation systems, air conditioning systems, cars, so on and so forth. There's materials and manufacturing engineering. There's electrical and electronic engineering, chemical engineering, biomedical, mechatronics, petroleum, among others, right? So if you look at history, engineering profession didn't just start in the 1800s, right? It became formal, right? It became a formal profession. There's training involved, education involved. The engineering profession dates way back before the 18th century. People have been designing materials and structures since time immemorial. Back in history, limitations imposed by practicality and cost were much more severe, right? Why? Because people back then had to overcome a lot of challenges just to achieve simple structural feats in order to build structures that can last, right? So on the right, we have the Hanging Garden of Babylon. It's no longer around. This was one of the seven wonders of the ancient world, right? This has been recorded in history. It's marvelous size and structure and beauty, but it's no longer around today, right? That's why it's called Seven Wonders of the Ancient World. We also have the Roman aqueduct, which was very important in Roman history to transport water, right? It's like a modern day piping system, right? Except back then, probably there's no people dumping methanol into the Roman water, right? Like we have today in Selangor, right? Causing a massive, water shortages, right? I'm sure Romans back then didn't have that kind of problem. I'm just kidding. Okay. Right. So one of this great structure of the past that I like to talk about is the Great Wall of China. It is one of the seven wonders of the world. It still exists. It stands there today in China. It stretches across its borders with Inner Mongolia all the way to Tibet. There's about 100 million tons of brick, stone, and soil transported during its construction. It's estimated. It's assembled by millions of soldiers, peasants, prisoners, and also animals using basic rope, wood, and basket systems. It's built across thousands of miles of terrain, from desert to river, from mountains to plains. So here we have a map, a GPS image of China. If you look at the red lines, this is all the remnants of the wall that we have today. Most of this wall is built under the Ming Dynasty, right? You can see it stretches all the way from Shanhai Pass at the Bahai Sea, all right, across the border of Inner Mongolia, all the way towards Western China, right, Tibet. On the right, we have a satellite image. There's a myth or a fable that says that you can see the Great Wall of China from space. Since then, NASA has sort of disputed it. You can sort of see it, but not really. But a lot of proponents of Chinese culture have said that you can see it from space, right? As a testament to the grandiosity of the architecture and the construction. The Great Wall was first built, right, by a duke in Qi State. He built a very tiny wall, right? I mean, it's not really tiny, but it's tiny compared to what it is today. The emperor that continued building it to what it is today is Emperor Qin. Right? This is Shi Huangdi of the Qin dynasty. He's the one who started massive building of the wall across Chinese borders, right? His goal was to prevent barbarians from invading China. And then there is the Han dynasty. During the Han dynasty, the wall was built to protect the Silk Road, right? It's a very important economic trade, right? Between China and the rest of the world. And during the Ming dynasty, the wall was restored. And the Qing dynasty, they're not so happy about the wall. They didn't run anything to do with the wall. They even forbade it, right? In modern times, the Chinese government began restoring the wall in Badaling in 1957, right? So that's the history of the wall. The wall was built for strategic advantage, right? At strategic places to repel invaders, right? Across different terrains. There's watchtowers, beacon towers built for observation so that the soldiers can communicate, right? Back to the capital by signal fire. The designers of the wall, right, made use of rivers and the cliffs as natural barriers, right? This not only controls strategic places, but also saved labor and materials. So the way it was constructed, the materials used were stone, soil, right? And some of this was heated in the brick kiln, along with some mud to bind the stone bricks together. The workforce used was mostly rebel peasants, farmers, prisoners, as well as slaves, right? The whip here, I believe, is just for imaginary purposes. I don't think it's proven that the whip was ever used in the building of the Great Wall. Okay. Nevertheless, the size of the manpower involved to build the wall was great and involved great planning because the terrain was so varied, right? There's mountains, there's rivers, plains, and deserts, and the resources around it was so limited. Some of the material had to be transported to the spot from far away, and so there was a lot of logistics involved, right? The material that they used to build the wall was also carefully chosen, depending on where they are and where was the closest place they could transport from, right? So this is an image of one of the watchtowers. As you can see, I'm sure some of this has been restored, but I mean, to build this kind of structure, you need some sort of calculation. You need material selection. You need to choose the right bricks, right, that is available. You need to process them, right, in the brick kiln. You need to also have mud that would bind them together strongly so that they won't collapse, right? So to ensure that such structures stand through the test of time, which in the case of the Great Wall of China, which is thousands of years, it involved great planning and great testing and great material selection as per se. And these are the things that engineers do today, right? To do material selection, to test materials, to see if they fail. And if they fail, how would you solve it? How do you improve the quality of the building material, right? So in short, there's a lot of logistics involved. A lot of the material was carried by hand. Some was carried using wheelbarrows and ropes, very primitive technology. Some was even carried using animals, right? However, history has somehow disputed the use of animal. It was doubted, and we're not really sure if animals were really used, right? Okay. Some people say goats were renowned for being good at climbing at the time, so people tied bricks on goats' horns and made them carry them up the steep mountains. Right? So in short, they were limited. Back then, the Chinese were limited by a lot of things, but they managed to achieve such a great engineering feat. Thousands and thousands of miles of a great wall built brick by brick, right? Bound together by mud that stood the test of time. Right, here's a picture of a tower that extended all the way to the seaside. Right, this is one of the watchtowers. So it extends from the Bahai Sea all the way across the border between China and Inner Mongolia, all the way to Western China, close to Tibet. Right, so this is a huge and magnificent feat, I would say. Right, so today the Great Wall remains one of the greatest feats from the ancient world. It involves colossal planning and organization of materials, labor, logistics, and construction, which is a modern parallel to engineering projects around the world. People who plan and design the wall may not know it, but they were engineers per se before the discipline even came about. Right? Okay, so that's basically the Great Wall. Next, I'll just bring you through the Great Pyramids, another magnificent feat that was achieved by ancient people. The earliest Egyptian pyramid was found at Saqqara, northwest of Memphis, dating back to the first dynasty. The otherwise earliest among these is the Pyramid of Djoser, built between 2630 to 2610 before Christ during the third dynasty. Right? This pyramid and its surrounding complex are generally considered to be the world's oldest monumental structure. The most famous of the pyramids are the pyramids found in Giza, in the outskirts of Cairo, the capital of Egypt. Right? Several of the pyramids are counted among the largest structure ever built in the world. Of these, the pyramid of Khufu is the largest. Right? It is one of the seven wonders of the ancient world, as well as seven wonders of the world. Right? So there's two lists. Right? There's seven wonders of the ancient world, such as the Hanging Gardens of Babylon, which no longer exist today. And then there's also seven wonders of the world, right? Which the Great Wall is part of, which are seven structures which are still standing today, right? So the pyramid is on both lists, right? If you look at the plan where the pyramid is built, some of you might say, right, these guys from thousands of years ago, they don't know anything better. They don't have smartphone. They don't have access to Google. They don't have GPS, right? They don't have software. But look at what they achieved, right? If you look at the map of the pyramid, in the center you have the pyramid of Khafre, right? The southwestern corner, you have pyramid of Menkaure. In northeastern corner, you have the pyramid of Khufu, right? In front of the pyramid of Khafre, there's boat pits together with the funerary temple of Khafre, and there's causeway linking it directly to the Sphinx and the temple of the Sphinx, as well as the valley temple of Khafre, right? If you look at the pyramid of Khufu, right? Adjacent to it are two cemeteries, right? Along with the causeway around the pyramid, right? As well as a neighboring village. So as you can see, these are not just a bunch of guys trying to put bricks on each other, right? These are people who, through great feats, planned voraciously using a ginormous amount of labor to build the structure up to what it is today. And they even have plans, right? And very detailed plans that is the testament to how much work and detail they put in. Right. So the Great Pyramid consists of an estimated 2.3 million blocks, which most believes have been transported from nearby quarries. The Tura limestone used for the casing was quarried across the river. Right. The largest granite stone in the pyramid found in the King's Chamber weighs from 25 to 80 tons. And these are transported from Aswan, more than 800 kilometers away. 800 kilometers away, that's far, right? That's far. That's like from Johor Bahru all the way to Alostar, right? Right. So these guys don't have cars back then, so they transported all the stones with rollers, simple structures, right? And just imagine the amount of challenges that they face along the way, right? Ancient Egyptians also cut stone into rough blocks by hammering grooves into natural stone faces, inserting wooden wedges, and then soaking these with water, right? As the water was absorbed, wedges expanded, breaking off workable chunks. Once the blocks were cut, they were carried by boat up or down the Nile River to the pyramid. It's estimated that 5.5 million tons of limestone, 8,000 tons of granite, 500,000 tons of mortar was used just in the construction of the Great Pyramid, right? Right. There's dozens of other pyramids around Egypt, right? In just the construction of the Great Pyramid, this is the amount of material that was used. Right? There's also a mystery which surrounds how the pyramid was actually built. There's several theories. The Greeks believed that slave labor was used. It could be very well possible. Modern discovery suggests that it was built instead by tens and thousands of skilled workers. Right? So when they check the sites, it seems that there's a lot of tools laying around belonging to tens and thousands of people. So what modern experts are saying that these guys were probably not slaves; they were probably skilled workers, right? Skilled masons, right? The expert Werner posited that labor was organized into a hierarchy consisting of 100,000 men, right, divided into groups of 20,000 men each, which may have been further divided according to the skills, right? So as you can see, there's like project management involved here. There's material selection, there's like material testing, there's planning, right? They even drew the plan, right? And then they have project management. They were organized back then, right? So as we said, there's a mystery surrounding the pyramid's construction. One of the experts, John Romer, suggested that they used the same method that they had been used earlier and later construction, laying out parts of the plan on the ground at a 1-to-1 scale. He writes that such a working plan would serve to generate the architecture with precision, right? There's also other theories involved, but what we know today is that nothing is clear. The Egyptian pyramid construction techniques remain a mystery. Nobody knows for sure how they achieved such a ginormous feat. So here's the entrance to the Grand Gallery of the Great Pyramid of Giza, right? And here's a view outside the Great Pyramid. So today, a lot of tomb robbers and other vandals in ancient and modern times remove most of the bodies and funeral goods. There's a lot of treasures inside, right? A lot of pharaohs' treasures inside. A lot of them have been plundered. Some of them have been displayed in museums across the world. But a lot of the valuable belongings of the pharaoh have been stolen. So today, the Great Pyramids no longer reach their original heights. Khufu, for example, measures only 451 feet, which is only a fraction of its original height. However, millions of people continue to visit pyramids. The splendor of these structures remain, as well as the mystery of how the Egyptians engineered the construction of the Great Pyramids. All right. So next, I'd like to bring you fast forward to the 1800s. Right, the 1800s, bring yourself to the United States of America, Chicago in the 1800s, right? 1850s and 1860s to be exact. Now, this is what Chicago looks like in the mid 1800s, right? There's a lot of mud on the street. Most of it is horse manure. Some of it is the sewage from the houses. The way Chicago was built is that Chicago is right beside the Michigan Lake, and it's slightly inclined. So the first settlers in Chicago thought that you can just use gravity to channel the sewage to the lake. What happened is that in the end, when the city grew, there's an accumulation of all this sewage, and a lot of it gets blocked. So you get a lot of manure, horse manure, human manure on the streets, right? Blocked and unable to flow to the lake, right? Even though there's some gravity involved, right? So during the 19th century, elevation of Chicago was a little higher than the shoreline of Lake Michigan. There was little or no naturally occurring drainage from the city surface. The lack of drainage caused unpleasant living conditions, and standing water harbored pathogens that caused numerous epidemics, right? So as you know, if you have a lot of animal and human manure on the streets, you get diseases, right? So there was a spread of typhoid fever, dysentery, cholera, which in 6 years in a row in Chicago, culminating in the 1854 cholera outbreak, it killed 6% of the city's population. The crisis forced the city's engineers and aldermen to take drainage problems seriously, and after many heated discussions, they decided to build a drainage system underneath the existing buildings. In 1856, engineer Ellis Chesbrough drafted a plan for the installation of a citywide sewage system, submitted it to the council, and was adopted. So what happened then was workers laid drains, covered and refinished roads and sidewalks with several feet of soil, and raised most buildings to the new grade. The process took more than 20 years, right? And was accomplished by literally raising the city. You know the jack that you use when you have a punctured tire? You know, you get a nail into your tire, it gets punctured, you drive to the side of the road. You take out a jack from the back of your car and you jack up your car. That's what they did in Chicago in the 1800s. They used hundreds of jacks and dozens of workers to basically lift buildings, right? All at the same time, right? It took about 20 years. Once they lifted the building, they put in all the pipes, the cement for the sewage, right? To direct all the sewage to the lake. Buildings were lifted up by dozens of men, turning dozens of jacks in unison so that the new foundations could be built underneath. So this is how it looks like. This is the Briggs House, one of the first buildings to be raised in Chicago, probably in 1866. As you see, what they did was put jacks, hundreds of jacks below the building, and then get hundreds of men to crank the jack up gradually, right? Together, right? In unison, right? Here's another picture where they raised the entire street, right? And what happened was when they raised the building, a lot of these buildings were moved outside the city where the owner wanted it to be positioned. Right? Many of central Chicago's hurried erected wooden frame were considered inappropriate. Right? And people were getting rich, so rather than raise them several feet, a lot of the owners preferred to relocate these old buildings outside the city and to replace them with new masonry blocks, right? Stone buildings. Right? Consequently, the practice of putting the old multi-story intact and furnished wooden buildings on rollers and moving them to the outskirts of town was so common, it was considered to be nothing more than routine traffic. So on a typical day in Chicago in the 1850s and 1860s, you would see people jacking up buildings instead of cars that we see today and moving the buildings around the city. It was a common sight. Traveler David McRae wrote, "Never a day passed during my stay in the city that I did not meet one of these houses shifting their quarters. One day I met 9." Right? So this guy, David McRae, he wrote that he met 9 buildings moving around the city. Right? Can you imagine buildings moving around in the city? Right? And then there's hundreds of men like jacking it up and rolling it from one place to the other. Right? A family could begin dining at one address and end up eating meal at another, and the shop owner could keep their shop open as long even as their customers had to climb in through a moving front door, right? So to give you an idea, this is Chicago today, modern city, complete with a top-notch sewage piping system underneath. And Chicago back then wasn't so pretty, right? This was Chicago back in the day, in the 1850s and 1860s. Right? So to achieve this, engineers had to plan the jacking and the laying of all the pipes, the sewage pipes underneath the buildings. A lot of the buildings were moved around. The older ones were moved outside the city and they built new ones, right? Until they achieved a state where the sewage was no longer sent to the street, instead to the lake instead, right? Right. Okay, so that was the raising of Chicago in the 1850s and 1860s. Right, so today in the 21st century, we have come a long way from the Great Wall, and we've come a long way from the Great Pyramids, as well as from the manure-laden streets of Chicago. Today, for example, we have skyscrapers, we have towers, we have new construction techniques, right, to build larger buildings faster, right, with the state-of-the-art technology. The second picture here, this picture in the center here is an electric shuttle in a typical North American city where it's run on electric batteries. The frame is built using 3D printing, right? So 3D printing is a new technology where you can use the 3D printer to print the structure that you want, that you design, cheaply, fastly, right? And this, what's special about this shuttle is that it also moves around using artificial intelligence, right? So there's algorithms programmed to the car that it drives itself, right? Using a self-autonomous driving system, right? Here, the third picture on the top, on the right here, we have what you call the Large Hadron Collider, right? This is a structure that is underground between France and Switzerland. It's used to increase the speed of a proton close to the speed of light, right? If Einstein was correct, if we can reach the speed of light, then we can travel through time. Now this equipment here can speed protons up to a speed of near to speed of light. It's 3 times 10, I think it's 3 times 10 to the meters per second slower than the speed of light, right? So that is quite something, right? And then here, a picture at the bottom, we have a Chinese city. Here we have a massive amount of solar panels, right? China is slated to become one of the most renewable cities in the world because they're planning on laying a lot of foundation to build renewable energy systems, such as solar system in this case, to harness the power of renewable energy, right? Here at the bottom, we have what you call Japan Society 5.0. You see a young lady with a drone. Japan has a bit of a different outlook for technology. Because Japan has a lot of older people, they want to achieve a state where they want to use robots to help old people around their daily lives. So the way they're going to do it is they call the whole concept Society 5.0, where they get self-driving buses, drones, robots to help elderly population get on with their lives, right? Instead of young people, servants, or Indonesian maids or Filipino maids, Japanese are planning to use robots and drones, self-driving vehicles to do that. They call it Society 5.0, right? Okay, so that's basically a bird's eye view of what engineers have done in history, right? Uh, back back in the days of the pharaohs, all the way to the ancient China, and then all the way to 1800 Chicago up until today, right? So now I'd like to talk to you about materials and manufacturing engineering. Right, this is a discipline out of the many disciplines. Today, the talk is basically focused on materials and manufacturing. So what is materials and manufacturing engineering? Well, first of all, new materials have been among the greatest achievements of every age, and they have been central to the growth, prosperity, security, and quality of life. Right? Imagine if back in the day, the Great Wall was built using substandard bricks, right? The barbarians invaded China, right? Then China wouldn't be able to blossom and grow until what it is today, right? It would have been invaded by the barbarians from the north, right? So materials have always been important throughout the history of human. It is always new materials that open the door to new technologies, whether in any discipline at all, right? It's the materials that add value, right, to the new technologies. Material science and engineering influence our lives. Each time we buy or use a new device, machine, or structure, it is the properties of materials that give it value, right? So in materials engineering, that is what engineers look at. They look at the properties of the material. Right? They look at the material, if it may be chosen for its strength, is it strong enough? Right? Can it conduct electricity? How well does it conduct electricity? Is it resistant to heat? Can it withstand corrosion? Right? Or a host of other reasons, but they all relate to properties, right? So on the right here, there's an image to show you one of the strongest biomaterial that has been recently discovered. It's called the spider silk. It's made from wood and plants, right? So the source is natural, and it's one of the strongest materials out there that you can find today. Right? Useful properties of material are linked to its structure at all levels, including which atoms are presented, right? How the atoms are joined and how groups of atoms are arranged throughout the material. We learn how this structure and the resulting properties are controlled by the processing of the material. Finally, materials must perform their task in an economic and societally responsible manner. So this is what the materials engineer do, right? Materials engineer understand the relationship between properties, structure, processing, and performance, right? Which makes the materials engineer the master of the engineering universe, right? I could be biased because I'm a materials engineer, but I believe it's true, right? Manufacturing engineers, on the other hand, take raw materials and basic components and turn them into products, right? So at UTAR, there's a merging of two disciplines, really, materials and manufacturing, right? So you get the study of the atomic properties of materials, and then you get the manufacturing side, how to put them into production, right? And the program at UTAR offers both education and research for development and application of new materials. It aims to provide graduates with an in-depth knowledge and understanding of the characteristics of all the materials. Right? So of course, as part of the program, students will apply principles of sciences and engineering to understand characteristics of the materials and also manufacturing. The program contributes to scientific knowledge and bridges the gap between chemistry, physics, manufacturing, and mathematical analysis, right? So you need to have some foundation of chemistry, physics, and also mathematics, right? And it's designed for graduates to be equipped with technical knowledge and skills required by many companies and industries out there, right? So once students graduate, materials and manufacturing engineers, they can find work or jobs in process engineering, quality control, research and development in various industries, materials related research in multinational companies and research institutes, semiconductor fabrication, nanotechnology, nanomaterials, special metals, composites, bioceramics, sustainable energy, and fuel cell applications, right? As well as solar cell applications. So there's a wide range of companies that will hire the materials engineer in the industry today, right? Just a list, to give you a list of some of the companies that hires at UTAR includes Mitsubishi Electric, Press Metals Sandiram Berhad, Mayfair Manufacturing Sandiram Berhad, NYKK, right? Some of these companies are air conditioning companies, some are materials testing companies, some of them are electrical application companies, right? So these are just some of the companies that's hiring through our program, right? So if you're interested, the contact person would be Dr. Yeo Wei Hong. This is the head of the Department of Mechanical and Materials Engineering, right? You can drop in an email if you would like to know more about the program, or you can ask me questions at the end of this session regarding the program, or anything you'd like to know about the job market as well as prospects in the current economic setting, right? So I also made a list of some of the projects that students get involved. These are our final year projects, right? Some of our students get involved in recycled plastics for building industry, right? For construction, using recycled plastics. Also in the textile industry, using recycled plastics, right? Using natural dye, right, from fruits and vegetables for the application of solar cell, dye sensitized solar cell. That's a type of solar cell. Also, the studying the effect of different electrolyte on the performance of the aluminum air battery, development of electrolyte-based aluminum air battery, thermoelectric refrigerator driven by nanostructure-based solar cells, carbon additive in lead acid batteries. Right? So these are some of the projects that our students do, right, for the final year project. A final year project is where the student teams up with a lecturer, and together they conduct test work, or it could be a simulation using a software on a certain topic, right? These are some of the topics that the students do, right? The time is about 2 semesters, right? So each semester is about 4 months, so total of 8 semesters, right, for the whole project. And the project will give the student an idea of what kind of projects that they might get when they go out to work, right? Of course, there's different ranges depending on which field and which company the student end up working with. But it will give the student a great foundation in terms of technical skills, as well as good exposure. Some of the projects are also very closely related to industries, where we get the companies to come and work together with the student on the topic, and the company will be a consultant. Sometimes the company would act as a client, right, to help direct the student and help the student develop his skills. Okay, just so you know, UTAR has been consistently ranked in the Times Higher Education ranking. In Malaysia, we have been recently ranked as #2 in Malaysia, right? #2, that is a great achievement. Right after UM, right? After University of Malaya is UTAR, right? Okay. So with that, I would like to go into the question and answer section, right? Here, the picture is taken in Chile 5-6 years ago. I was there. I was lucky enough to be hired in a Chilean university in Latin America, South America. I was there for 2 years. This was a picture I took in the desert in the San Pedro de Atacama, where it's one of the driest desert in the world. There's a lot of volcanoes and geysers there, as well as a lot of llamas. Llama is a sheep-looking animal that's you can only find it in Peru and Chile. Right? So this is a picture that we took in front of a small chapel in the desert, right, back then. So I mean, engineering is a great way for you to make a living, to support your family, but at the same time, it also offers, for me, at least in my case, it offered me a chance to travel the world, to look at different places, to learn different cultures, and to see different things, and meet friends along the way, right? So it's not just about building buildings or building cars, making the latest technology. Sometimes if you choose engineering, it can lead you down paths where you can meet new people, learn new cultures, and expand your horizon and travel, right? All right, so with that, I would like to open the floor to questions. Any questions that you have? Right?
Yep. Hi, Dr. Kwan. I'm back.
Hi, Ken. Yes.
Yeah, thanks for the sharing. I think it's quite very informative that actually let us know actually engineers have been involved since the very ancient time until like the pyramids and also the China Great Wall. Okay. In the meantime, when Dr. Guan is sharing, I just posted evaluation form in the chat box. So for participants, I actually need your help. If you have any comments regarding our this webinar, feel free to fill up this evaluation form. In the meantime, if you have any questions, feel free to leave your question in the Q&A box available in this Zoom conference or in the chat box as well. Okay. So yeah, while waiting our participant to fill up the form and also typing their questions, I would like to ask Dr. Guan. Just now you did mention about actually a lot of improvement are starting from the material first. Like any
Correct.
example that actually the latest material that been using in our daily life but we are not aware of?
Example of material used in daily life you're not aware of.
Mm,
You know, your smartphone. There's a lot of components in there that uses rare earth materials, rare earth metals. Rare
okay.
metals are a series of metals that is on the periodic table, such as lanthanum, cerium, cesium. In Malaysia, it's been a controversy. I'm sure you heard of Linas. Linas
Mm-hmm.
was here from Australia. They decided to process rare earth from Australia, highly polluting. But a lot of this lanthanum and cerium is used in smartphone components. Right? Other metals are not able to replace rare earth metals yet. That's why we have to live with them. The problem with rare earth metals is it's very polluting. As in the case of Linas, they haven't decided where they want to put all the waste. They have not decided where they want to also I mean, as far as I know, they haven't decided where they want to put the waste. So it's controversial. But whenever you use your handphone, inside there are components probably using rare earth materials and probably from a company like Linas. This is one of the examples.
I see, I see. Okay, quite interesting. So means the cell phone actually contains some rare metals. Okay, that's interesting. Yeah, beside that, I actually would like to know like this pandemic, right, is actually affecting everyone. So like, does it affect like the engineers? Will engineers get affected?
Well, Ken, I mean,
Mm-hmm,
if you read the news, I mean, the pandemic is affecting everyone in the world, right?
mm-hmm,
Not just Malaysia, even in countries around the world like US, Australia, right, Canada. Of course, it has an effect on the economy, but a lot of analysts are saying that by next year, most economies will come back, especially Asia, right? Especially China. China has grown 1% this year, and if you look at the amount of damage COVID has done there, it's quite gigantic. But then they managed to still grow by 1%, right? For us, Malaysia, I think we have a negative growth this year, a few percent. But a lot of people are expecting by next year we'll be back on track, right? Hopefully we'll get a vaccine, but life goes on. Of course, we are affected, but as I've been monitoring, there's been companies looking for students. There's a company looking for graduates.
mm-hmm.
They've been posting. They've been asking us. We've been posting on our Facebook page, right? Companies are looking for engineers. I mean, the world has to go on. We have to move on. So, I mean, a lot of industries have to move on. So, yes, there is an effect, but I think we will get back soon. Right? Yeah.
Okay. Thanks for the sharing. Yeah. In the meantime, like just now I was sharing about our fresh graduate actually get employed by those company. Like, have any ideas? Like, now's parents actually quite curious lah. If my son or daughter go for this engineering program, roughly how much like the salary we're getting for their first job? Just based on experience lah. Just sharing.
Well,
Like,
it really depends what
mm-hmm,
company you work with. I mean, there's a lot of engineering company out there. I
mm-hmm,
know if you're a parent, you're worried about how much your son will be making, how much your daughter will be making. If you're working for a large multinational, international company, the salary will be obviously high. If you're working for a mid-sized or small-sized company in a small part of Semenye or Kepong, obviously the salary will be lower. But on average, students make 2,000, high 2,000 plus to low 3,000 plus as a starting salary. So, I mean, between 2,800 to 3,200 plus or minus. That's an average. Of course, if you end up working for large companies, large oil companies, the salary will be significantly more. Right? It depends which industry you end up with. It depends what company you're working. But I wouldn't say you should be disappointed with 2,000 plus, 3,000 plus because in engineering there's a lot of opportunity for growth, right? If your son or your daughter works hard, has the right attitude, of course, he can be promoted, right? I have friends in the industry. In 5 to 10 years, their salaries increase enormously. They get paid for what they do. They also don't stay in one company, right? If you're good, you can move to different companies and people will hire you, right? And if you create a reputation for yourself in the industry, people know who you are, right? They know Tan, and Tan does a good work, and then the clients recommend Tan. So Tan can have no problems getting a job anywhere in the industry because he's hardworking, he has a good attitude, he's professional, and the future is great for Tan because he'll be promoted and his salary will be reflected.
Okay, okay, okay. Interesting. Thanks for sharing. And another question is like any interesting research that you can share with us, like you're currently handling any interested research you're ongoing?
Currently, I'm looking at kaolin. Kaolin is a white powder that is used in cosmetics. If you're watching a lot of Korean series, you probably know, Korean actors, they use a lot of BB cream and all that. So in all those cosmetics, there's a lot of kaolin, right? Kaolin is also used in the paint industry as fillers, right? So the thing about kaolin is it has to be very white. If it's yellow, people won't pay money for kaolin. And the reason that it's yellow is because of the Fe content, iron content. So currently we're looking at ways to extract the iron from the kaolin using bacteria. Why do we want to use bacteria? Because if you use the traditional method of magnetic separation or the chemical separation, it takes a lot of, it costs a lot and it takes a lot of electricity, right? So in the long run, it's not very good for the economy. It's not very good for the environment, right? So bacteria, you can just find from the environment and throw it in there, and then the iron will be extracted. So we're looking at that. We have achieved about 53% extraction so far. So we're looking to extract it to even more, hopefully over 80%. And if that's feasible, then we can link up with a lot of companies in Malaysia and China as well. I have a great collaborator, Dr. Lawrence Ho, Prof. Ho in China, and he's doing a lot of great work over there. As a matter of fact, I think some of his students is listening to this live webinar. He's doing a lot of great work in China, in Guangzhou at the university, SUSTech, and he's doing similar work in Kowloon.
Okay, okay, that's good. There's one questions from the floor. Can you see on the Q&A section? The Q&A tab, you just click on the Q&A tab, you will see the questions posted by Hao Chun Long. Yeah.
That's actually Prof. Ho, yeah? My collaborator in China. Would you kindly list some of the up and rising engineering disciplines globally and locally in Malaysia? Yeah. Well, I think what are in Malaysia? I will start in Malaysia. Malaysia, I think the current big topic is energy. Energy is important. We'll have an energy crisis soon if we don't come up with a way to replace fossil fuels. And some of the disciplines have been biomass energy, right? Biomass also. Especially the use of bioethanol, right? A lot of people have been talking about fourth generation bioethanol. I know it's been a bit oversaturated, but in the context of Malaysia and Asia, we're still looking at ways where we can harness energy from waste, right? Use, for example, all the restaurants and all the agricultural waste. It would be nice if we can take all those, ferment it, generate energy from it.
fermentation, and then use it to harness to power generators, right? So that's in the context of Asia. Globally, in terms of global scene, it depends where you're talking about. I know in Japan, they were big on robotics, and they're still trying to apply robotics to daily life using the concept of Society 5.0. In Europe, there's been a lot of talk on sustainability. Of course, biomass energy is one of the sustainable ways to achieve sustainability. But in Europe, they're looking at multiple ways to reduce fossil fuels. The government in Europe is taking a proactive part by. I know the UK government has decided to ban diesel cars once and for all. Diesel is very bad for the environment. They decided to ban it, and they are giving it, I don't know how many years. In the recent future, there won't be any diesel cars in UK anymore. In Sweden, we have Volvo, who is planning to go 100% electric by the next decade, I think, right? So depending on which part of the world you're looking at, you have different fields that's emphasis of different governments around the world. I hope that answered your question, Prof. Ho. Maybe you'd like to add a few words on that. Prof. Ho. No mic. Okay, all right. No problem. No problem. Thanks for asking, Prof. Ho.
Okay, so yeah, I think, is there any other questions? If no, then we can end our webinar today. Yeah, thank you so much for everyone for tuning in this webinar, and also thank you so much for Dr. Kwan for your sharing section. Okay, hope everyone's staying safe as this pandemic are getting a bit serious. So once again, I hope everyone follows strictly on this SOP. Stay home and try avoid getting out if not necessary lah. So together we can overcome this pandemic. Okay, thank you so much. Thank you everyone.
Thanks, Ken. Thanks for
Thanks.
moderating.